Welcome to another 3D comparison video. This will be regarding SolidWorks. So this is an overview regarding mold tool design. So we're going to see over here how we can define the following components. So we're going to have the core, the cavity, and the design part over here. Now, by the end of this video, our part will look like something like this. So initially, we're going to start with a simple revolve over here. I'm going to do some cutting over here so we can better understand the drafting orientation in this case. And afterwards, we're going to go within Mold Tools and take this part within all of those features in order to obtain the following assembly. So let's get started. I'm going to start initially from the right plane. And over here, I want to create a profile with revolve. So I'm just going to create a vertical line. After that, I will create the following profile. And I will now close this with a line. Keep in mind that if you want, you can also go ahead and design like this, then move the mouse to the point, and this will give you an arc. As you can see over here, you can move it to the point, and after that the line, so you can also do it like this. So you don't have to swap that many features. Now I want to have tangency between those two, so select those with Control and add tangency. I'm going to add some dimensions, so let's say 30 over here. I want a radius over here of 10. This will make it as following. I can now go ahead and I can close the profile, and I'm going to use the revolve in this case to define the following part over here. Now, within the other case study, I only had the radius set over here to 5 because this is currently a little bit heavy filleted on the side, so I'm going to go with this profile. Now, on the top section, I just want to create a simple circle because I want to see that drafting and how that angle will influence this. So I'm going to add the initial circle at 15 over here, also onto the other axis, so over here as well. I can add the dimensions, let's say 10 in this case. And I want to do a circular pattern for this. So I'm going to go within feature. I can also go ahead and I can do it directly within sketch. So I can remain within sketch, have that selected, define it over here. And SolidWorks will automatically move that point to the middle. If you didn't use that as the origin, you can change it over here as well. Now we have that defined, and over here I will just do an extrude cut. I can keep this through all, and this will be the following profile. Now, when we are designing those mold components, it's important that we're going to have the possibility to have an angle over here that will help the molds to be separated from the core and cavity in this case. Now, in order to do that, we are going to use draft angle. So I'm going to enable over here the Mold Tools. If you don't have this enabled, you can right click, go to tabs, you can activate Mold Tools. I'm going to find over here. And we're going to have this draft analysis. So I need to specify the direction of pull. In this case, I'm going to select the top plane over here. And we're going to see that with an analysis, for example, of 2 degrees, I'm going to have the following. So this section will be a positive draft. This will go along with the top cavity in this case, and what is over here with red, this will go with the bottom cavity. The only problem lies over here within the inner circle, so those will need to be drafted. If I'm going to hit OK, we're going to see that the draft analysis still remains over here, so I can enable it and disable it over here. But if I will have to re-enable it, again, I will need to select that direction of pull. Now, we also have draft over here, and we're going to see our draft will add those angles onto those faces. You can also go ahead and you can select those manually, but again, you're going to need to select that direction of pull. Afterwards, the faces that we are going to draft, you're going to add the value over here, and by hitting apply, you're going to see how those will go. So if I will just hit OK, we're going to see that, okay, let's see, drafting didn't really work over there. So I'm going to go with this one. It's the same feature. So again, I'm not gonna use the draft expert, I'm gonna go for manual because this was the problem. So I'm just gonna select the pulling direction, those elements that will be drafted, and over here we see that I also have that arrow. If I will add over here too, if I'm gonna hit OK, we're gonna see that now if I will go within, for example, the top view, I'm gonna see that this circle will have this one over here within the interior, and this one, if I'm gonna zoom out, will be at the exterior. So we have those drafted taper walls set like this inwards. If you want to swap that, you can right click over here and you can reverse the direction of pull. That will reverse that small arrow. And now if I will go again within the top view, I'm going to see that from the top view, I can no longer see that bottom circle. But if I will slowly rotate, I'm going to see that it will actually be over there. But now this will be visible from the bottom view. So from the bottom view, we have that section over here. So keep in mind that regarding the angle for the draft, this will also influence how that mold will open. So in this case, I will just have this reversed. So I want the taper to be like this. That means if I will check the model like this from the top, this will be lower over there. If you want to maintain still the same orientation as the one over here, so that this will, the mold over here, I will have to reverse that. So let's just add it. So it should actually be like this. Okay, now we can go ahead and we can prepare this for Mold Tools. So I'm going to go over here with the Mold Tools. And we can also use the parting line over here. And this will be the tricky part because SolidWorks will, in some cases, not find that parting line well. And when you try to do the shut-off surface, it will not act that good. So I'm going to go for the parting line. We see over here again the direction of pull will be this one. I want this to be at 2 degrees because I did a drafting for 2. I'm going to do a draft analysis. And we're going to see that it will look like this. I can also check split faces. And now we're going to see that this section will go with the top part and this one will go with the bottom one. And now I can select this parting line because this will be straight in the middle of that radius. And this is well defined like this. I can now go ahead and I can do the shut off surface. And in this case, we're going to see that automatically Solid will try to shut off everything over here. But in this case, we actually want to do the shut off surface on the top because we want the bottom section to go ahead and slide out of that mold. So I'm going to select only the top sections over here and I'm going to hit OK. We're going to see over here that we have a notification that the mold is separable into core and cavity. So I'm going to hit OK and it will look like this. Now we need to extend this parting surface and we can go over here with perpendicular to pull direction. I can also have this increased. Let's say, for example, I'm going to add over here 100 millimeters. I'm going to hit OK. And now we need to go ahead and draw a sketch over here to design the tooling split. And that will define the core and cavity, and those should incorporate the parting surface. I'm going to go ahead and I will create over here a rectangle. Let's say that I want this to be 100 millimeters. We can further extend this because in reality we're going to have to add additional components to a mold like this. So I'm just going to make it like this larger. Now I can go within Mold Tools, I can enable the tooling split. And we're going to see that Solid will automatically define the core, the cavity, and the parting surface. And we can also specify how much material we need on both sides. I'm just going to leave this by default, in my case 20 and 20. Maybe if it's the first time that you're using this, it will only be to 10 millimeters on both directions because that's the default within Solid. So I'm going to hit OK. And now we have the following output over here. So we're going to have the surfaces. I'm just going to hide the solid bodies and I will hide those surfaces so we can better analyze what we have over here. We're going to have this shut-off surface, which will be the one on the top. we're going to have the core, which will be the one on the bottom. If I will hide this, we're going to see it will actually look like this. And we have the additional line in this case, which is actually the parting line. So these are the trimming that Solid has done over here in order to define those surface bodies. I can also hide those. And I will now showcase the solid bodies. So this one entitled parting line will actually be the part that we created, in this case the following revolve with 4 cutouts. This will be the bottom section, so we're going to have it over here. If I will enable the parting line also to be visible, we're going to see that those will be perfectly overlapped over here. And the last one will be the top section, so if I will hide the bottom one, we're going to have the following. Now we need to define an assembly using this part. So in this case, we have them nested over here underneath solid bodies. So I'm going to go over here and I will right click and I will click save bodies. But before we're going to do that, Solid will ask us to save the part, because we have over here the save bodies. I can auto assign some names for those. But we're going to see that we have a notification. This part has not been saved yet. Please save the part before the operation. So you also have over here that indicating that the file hasn't been saved. So I'm going to go over here within this. I'm going to call this part 3. And now I will go ahead and I will save the bodies again. I can auto assign them names over here. And I can also choose a location where I want that assembly to be defined. So I'm going to go over here and I'm just going to type in 1. I'm going to type in 2 because I actually have one over there with the same name. So in this case, let's see 3. This will have the following save type, so split assembly. This will actually be a solid assembly, but it will also have that split in front, but it's actually the same file format. And now if I will hit OK, Solid will go ahead and will save those. But we have over here a notification regarding the template used. So I'm going to hit yes in this case, over here as well. So for all of those 3 parts, you're going to have to click 3 times. Now we have this being rebuilded. And now actually what happened is that in the background, if I will go over here within window, I'm going to have this assembly created. And over here, all the components will be initially floating, but we can go ahead and we can move them. Let's say that I want to have this one fixed. So I'm going to right click and have that fixed. I'm going to move the part as well. And we can now go ahead and we can mate this together. So I want those 2 circles to be mated over there. Now we're going to see that I can still rotate this. And we need to add an additional mate. So let's say that that circle should actually mate over there. And now we only have this one. So that top section will be mated over there. And I can also choose these 2 sides. And in this case, I need an additional side over here in order to have this fully mated. Now I can no longer move the components. I can go ahead and I can create an exploded view over here on exploded view. Let's say that the first step will be this one. I know that within the new version, I think you need to check that this will be the first step. So let me just check because they slightly changed this. I'm going to hit over here done. After that, move the second component. Again, hit done. And now if you want to see that animated, you can right click. And we're going to have over here animate collapse. And that will actually put those 2 exploded view elements in motion. We can also loop this back and forth. So we have over here some controllers for this. I can hit play. I specify over here that I want this to be looped. You can also add this. So this will go up and down. So it will not jump any steps over here. Okay, so this was an overview regarding mold tools within SolidWorks. I hope you enjoyed this kind of content. I really like to design molds within Solid a lot better than within CATIA because I find this workflow to be a lot easier. Within CATIA, we're also going to have a specified workflow And I do consider to make some content for that as well. Okay, so I'm gonna add a similar video over here on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.